Hello students, in my last lecture I had explained refraction of light through spherical lenses and also some special rules which rays of light follow during refraction through convex and concave lenses. As we know that to represent image either by reflection or by refraction, we take at least two rays. So, out of the three rules which we had learned in our previous class, these were, see here, see. First rule was that, see, a ray of light parallel to the principal axis in the case of convex lens after refraction pass through its focus, but in the case of concave, a ray of light parallel to the principal axis after refraction diverges in such a way that it appears to come out from focus. Second rule was that if rays of light incident through focus of any convex lens, then after refraction it becomes parallel to the principal axis. And if rays of light incident on a concave lens in such a way that it appears to pass through its focus, then after refraction it becomes parallel to the principal axis. And third rule was that rays of light incident at optical center of convex lens don't change their path. They travel on its original path, and the same situation is for concave lens. Now, out of these three rules, we shall obey any two rules to represent image formation by convex lens in different 6 cases. So one by one we shall explain what are the different cases. So first, if the object is at infinite distance. Suppose in first case the object is at infinite distance. So we take a convex lens. Suppose this is a convex lens. This is optical center. This is our principal axis. This is our principal axis. This is optical center. This is our focus 1, F1, F2 and 2F1, 2F2. Why? For C, we can write 2F because we know that, what we know? We know that F is equal to R by 2 or R is equal to 2F. So this F plus F2F, that is center of curvature. If object is at infinite distance, then rays of light coming from infinite distance taken parallel to the principal axis, and in first rule we had seen that rays of light parallel to the principal axis after refraction from convex lens meet at a point on the principal axis, and this point is called focus. So see, what is the position of the image? So if object is at infinite distance, then image is formed at focus on other side of the lens, and so we shall write position of object, then position of image at F2. It is a real inverted and highly diminished, that is point size. So in this case, the image of object forms at focus f2, it is highly diminished, it is real and inverted. Now, as we had seen in the case of concave mirror, 6 cases. Similarly, for convex lens, again we shall see 6 cases, and with the change in object distance from the lens, position, nature and size of the image also changes. So, second case. Now, if object is brought towards the lens. Second case, if the object is beyond to f1, then what is the situation? See, suppose this is our concave lens, this is optical center, this is principal axis. Suppose f1 to f1, f2 to f2. If object is beyond center of curvature, that is beyond to f1. So, as we had seen, we shall take always at least 2 rays. We take 1 ray, suppose this is our object AB. This is object AB. So, we take 1 ray parallel to the principal axis of this convex lens, and after refraction, this ray pass through focus f2. This is first row, and this ray, to represent ray, is very much important. It is essential. It gives us the direction. And suppose second ray pass through optical center. Second ray pass through optical center. What we had seen? We have seen that rays of light passing through optical center does not change its path. Now, what happens? See, these 2 rays really meet here. And the point where these 2 rays meet really, a real image of the object forms. One thing is very important here, students. See, this is the head of the object. So, rays of light coming from A, that is head of the object, meet here. So, this position is A dash and this position is B dash. So, this is a real and inverted image. What we see? We see if the object is beyond 2f1, then image is at in between f2 and 2f2. It is real, inverted and diminished. We shall see 6 cases. And now, in our NCERT book, see, in page 178, table number 10.4, all the 6 situations are given. Now, see what are the informations given here. First case, starting from first case. What was given in first case? See, in first case, see here, position of the object at infinity. So we had taken object at infinite distance. What is the position of the image? At focus f2. See, image is formed at focus f2. The relative size, highly diminished point size. So see, highly diminished point size image of the object is formed. And what is its nature? Real inverted. Now, second case, which we have just explained. In second case, object is beyond 2f1. See here, beyond 2f1. In second case, position of the object beyond 2f1. Position of the image between f2 and 2f2. It is diminished, real and inverted. So, now, we did not write these things in all figures. Synopsis of all 6 situations are well collected here. So we explained here image formation, and informations are well collected here. What is the position of the object? what is the position of the image, what is size, and what is nature. We shall just explain one by one. So now see case number 3. In third case, suppose if the object is now B, bring object closer to the lens. Suppose if object is as 2f1. So if the object is at 2f1, then see what is the situation. This is our convex lens. This is optical center. Suppose this is our principal axis. This is focus 1, f1 to f1, f2 to f2. If the object is at 2f1, B, bring object gradually closer to the lens and see what is the situation. So suppose this is object AB, object is at 2f1. Once again we take one ray parallel to the principal axis. So the ray parallel to the principal axis, after refraction, pass through its focus f2. And now the ray passing through optical center does not change its position. So this ray passed through its optical center. What we see? We see in this case the image of the object forms at 2f2. This is the position of the image. So if object is at 2f1, then image is at 2f2. This is 2f2. This is situation 2f2, A dash, B dash. This is very important from the point of view of our numerical problem. If you want to solve numericals correctly, then the concept of ray diagram must be clear to you. Suppose in this situation, what is the position of the object? Object is at 2f1. Then what is the position of the image? Image is at 2f2. What is the size of the object and image? The size of object is same size to the image. And what is nature? It is real and inverted. So, dear students, if in numerical problem you have given that the size of the image is same size to the object, and suppose you have given focal length of convex lens, then just from the relation f is equal to r by 2 or r is equal to 2f, you will calculate the object distance. Here object distance will be 2f and image distance will also be 2f. Here height of the object h will be equal to the height of image h dash. So these are very important concepts which will be fruitful for us during solving numerical problems. So if you want really the practical knowledge of physics, then try 2 times, 3 times, or so many times to draw these ray diagrams. If these things will be set up in your mind, then numericals will be very easy to. Now, see situation case number 4. This is very important part of our numerical. So if now object is taken in between 2f1 and f1. So if the object is taken between 2f1 and f1. See what is the situation. Suppose this is our convex lens. This is optical center. This is principal axis. This is f1. to f1, f2 to f2. If the object is taken between f1 and 2f1, now see what is the situation. Suppose this is our object AB. Once again, we always take one ray parallel to the principal axis. Always, in all situations, we take one ray parallel to the principal axis. And what happens? After refraction, this ray passes through focus. So after refraction, this ray passes through focus. After refraction, this ray passes through focus. This is incident ray and this is refracted ray. And we always take another ray from optical center. So another ray is taken from optical center. See here, optical center. These rays really meet here. These rays really meet here beyond 2f2. So these rays meet beyond 2f2, and suppose it is AB, then it is A dash B dash. What we see? We see that in this case, the image is real, inverted and magnified. So this is the first case in which magnified image of object starts to form. In previous cases, what we had seen that if object is at infinite distance, then image is highly diminished. If object is beyond 2f1, then image was diminished. If object is at 2f1, then image is of the same size the object. But if object is now taken between 2f1 and f1, then image of the object is magnified. Now, in case 5, suppose if the object is taken at f1. Now object is taken at f1. See what happens. Object is taken at f1. This is our optical center. This is principal axis. This is focus f1. This is 2f1. This is f2 to f2. Now object is taken at f1. Situation has changed now. What will be the condition? See, object is taken at f1. Suppose this is object AB. Once again, we take one ray parallel to the principal axis. And after refraction, this ray passes through focus f2. This is incident ray and this is refracted ray here. And another ray is taken through optical center. So another ray is taken through optical center. See, optical center. What we see? We see that both these two rays after refraction becomes parallel. And in geometry, we have read what? That parallel rays meet at infinite distance. So in this case, image will be formed at infinite distance. It will be real, inverted and highly magnified. So now images are magnified. In 5 cases of convex lens, the images are real in nature. But now we shall see in 6th case, the image will be virtual. So 6th case, if the object is taken between f1 and optical center. See what is the situation. Suppose this is our convex lens. convex lens. This is principal axis. This is principal axis. This is optical center. This is focus f1. This is point 2 f1, f2 to f2. Now object is taken in between focus and optical center. Focus and optical center. This is the position of the object AB. So once again, as per our previous knowledge, we take one ray parallel to the principal axis. This is important thing and common for all cases, that we take one ray parallel to the principal axis, and this ray pass through focus f2. So this is incident ray, this is refracted ray. And another ray we take from optical center. Another ray we take from optical center. What we see here? We see here that these two rays diverge. That is, the distance between these two rays increase gradually. And it is not possible for these two refracted rays to meet really. What happens in such situations? We proceed rays in back. So when it is proceeding back, dotted line. So if these two rays are proceeding back, then it appears to meet at this point. So in this case, the virtual and erect image of any object forms. So in this case, what we see? We see that object is taken between focus f1 and optical center, and the image is formed beyond to f1. This image is virtual, erect and magnified. This is very important situation, because generally a student consider that convex lens are converging lens and always it forms a real image, but always convex lens don't form a real images. From convex lens also virtual images form, and this is the situation if object is between focus and optical center, then the nature of the image formed by convex lens is also virtual, erect and magnified. So once again, I suggest you to draw all these 6 cases, ray diagrams of all these 6 cases 2 times, 3 times or many times to really learn it. So dear students, your homework is that draw ray diagrams of image formation by convex lens. Thank you very much.